10.4 interference in thin films. Okay, so what is a thin film? Here is a medium, the film, and when the wave is coming, it will be constructive or destructive interference, and you will see some color on the top of that. So you have seen probably the swirling color on the spectrum that results when a gasoline oil is spilled on water. Those colors of the spectrum shining on a soap bubble, you have seen that. These effects are produced through the optical interference. When it reflected and transmitted, will destructively or constructively interfere. Okay, looking at this, when the light is coming from faster into the slower medium, the reflected one will be inverted by 180 degrees. Okay, if you imagine that this is my wave, and I'm saying that this is inverted, it becomes like that. See, the maximum become minimum and the minimum become maximum. So it's just 180 degree will be shift. Okay. So here is gonna be 180 degree or lambda over 2. If you just shift this one by lambda over 2, see? You shift this one by half of the lambda, so the minimum will be on minimum and maximum on minimum. Basically shift the whole things by half of the lambda. See, this is the half of lambda. When you shift this one by half of the lambda, this minimum will be here, right? 180 degree is just kind of shifting your wave half a lambda. Okay. So then you have a transmitted wave. So from any transmitted wave is not going to be inverted, just passing through without any shift. And here, this one will be from a slower to the faster, right? And when it's reflected, you do not have any inverting here. The phase here and phase from here to here will not be shifted by any angle. Also here is not, but since it's going down and it's going up, it would be path length. If the thickness is T, 2T, it will be the path length that it's going through. If it's 2T, is 1 lambda phase shift, right? Then this one going through half a lambda, because it's gonna be inverted, right? And this one going through a lambda shift, the rate 2 is going down and up, you have a path length. When something is shifted by lambda, make sure what is happening. Just gonna make a picture. If you shift this one by lambda, you will get the same thing, right? If you shift this point by lambda, again, you have your maximum on a maximum. It's going to be the same thing, right? So So basically, what is that? The difference between these two. So this is shifted by lambda, which is means change nothing, and this is shifted by lambda over 2. So phase change between the 1 and 2 is a lambda over 2. See the difference between these two are lambda over 2. And two things is shifted by lambda over 2, the maximum and minimum will coincide. You have a destructive interference. But let's say this T, here T is equal to lambda over 2. Now let's say this 2T is, okay, give me a second. Say these 2T is equal to lambda over 2. Okay. So then this one, the number 2, will go under phase change, phase shift of the lambda over 2. Okay. So these two, the difference between their phase shift will be 0, right? Means they will be in phase, and two things are in phase, means their maximum and the maximum and the minimum are coincide, and they add up constructively. So when the T is lambda over 4, they add up constructively. When the T is changing the color here. And the T is lambda over 2, they add up destructively. Okay, the summary is here. You can see that. And the T is very, very much more than the lambda, means it's going up and down, will not do any phase change, right? This distance that they travel are much more less than the wavelength, so it's negligible, this distance. That's why this is coming here and this is coming, it will be in phase and construct. So since here is inverted lambda over 2, that would be a destructively. Here, no phase change. Here, by half of the lambda. So the difference between them going to be half. I think these two rays gonna be half a lambda, so it's gonna be destructive. Here is lambda over 4, T equal to lambda over 4 is going to be constructive interference. And here the T here, half of the lambda would be destructive interference. Here, if you wanna look at, let's say your eye is down here. Here your eyes is on the top of the film and you will see that there. But in this picture, you're looking, your eyes is here looking at that. There. Here is the soap. So this is comes, maybe I just make it bigger. This is coming, passing through this from the, well, not making phase shift. So it's come here and there will be no phase change for the ray 1. Here it comes, and since it is going from the slower to the faster, it's not going to invert it. And here is the same thing. It's from the slow to the fast, not going to invert it. And the path difference is negligible. The length that is going up and down here is negligible, right? Up and down here is negligible. Means you don't need to worry about this path of taking. So it would be no phase shift between the ray 1 and ray 2. But there will be not inverted here and not inverted here. But the path length is going through for the ray 2 is going up and down. It's not T is lambda over 4. Means the phase shift for the 2, because of the path difference it's taking, It's going to be land over 2. It's going to be twice of that, because go up and down. And this one, as you know, is coming without any shift. That's why the phase difference between 1 and 2 is just land over 2, and will be destructive interference. In this case, here it comes, no path, no, nothing changed. But when it's coming up and down, the path difference that it takes is twice of that, is lambda. So when two things is the lambda by shift, so they construct the minimum or the minimum and maximum or the maximum. There's going to be constructive interference. Okay, looking at this question. In summer month, the amount of the solar energy entering a house should be minimized. Window glass is made energy efficient by applying a coating maximize effect reflected light. Light in a mid-range of the visible spectrum at 568 nanometer travels into energy efficient window glass. What thickness of the added coating is needed to maximize reflected light and thus minimize transmitted light? So we want to make it reflected, means it should be constructive. Here is the shape of that. So you have a coating here, the rays coming, and we wanted this to be reflected. So since the N of the coating is given 1.4, I know the N is land of the air over land of the coating. Land of the air is given to you. It is 568. So we just rearrange for land of the coating. We find the land of the coating. And the thickness, if you wanted this one to be here, we wanted this to be constructive, so all reflected back. The thickness should be land over 4. The thickness should be land over 4. T is going to be land over 4. So if we got the land over the coating, land over 4 is 460 divided by 4. The thickness will be given in nanometer. You can turn it into millimeter. For practice, you can do question number 1 and 2.